Hello, everybody, and welcome back to our class. Today, as I said to you last time, we will have a quick review on the previous chapter about the confidence intervals. As I said to you, this chapter is very, very important because by this chapter you can estimate the parameters we are interested in. Here in our class, we have two parameters we are interested in, the population average and the population proportion, or sometimes we call it the probability of success from binomial distribution. We will start with the first question today. As you can see here, it's very important to know what parameter we are talking about in each scenario we will have in this part. So you have to read carefully the question, identify everything there, and then start to solve the question. First of all, we have a poll here asks visitors to a website for the number of hours spent web surfing daily. The poll gets 223 responses one day. The average response is 3 hours per day with S, of course S here is the standard deviation, 1.5. Construct a 95% confidence interval for the average time this website's visitors spend surfing the web daily, assuming this day was representative of their visitors in general. So first of all, as I said to you, you have to identify the parameter in this scenario. Our parameter here is what? Is it the average? Is it the proportion? Of course, from the scenario here, it's obvious it's about what? About the average. Why? Because it says construct a 95% confidence interval for the average. Okay, so here you know now that we need to estimate what? The population average, mu. This is our parameter. Okay, we need to estimate, of course. Of course, to estimate it by the confidence interval, you have to be familiar with the formula, right? So the formula here, if you remember, the 95% confidence interval is, let me write down here. So we can estimate by two things, actually three things. First, the point estimate is x bar, the sample mean, plus or minus. The standard deviation is S divided by square root of n. This is the standard deviation. And we need some confidence from the sampling distribution of the sample mean. And in this case, because we have here S instead of sigma, we have to find this confidence from T distribution. So in this case, we have here T score. And if you remember T score, to find it, you need two things. You need the confidence level, and we have here 95%, and the degrees of freedom. And the degrees of freedom here is n minus 1. Okay? So we need here T score. Okay? Okay. So we have the average, it says here, from the pool gets 223 responses one day. The average response is 3 hours per day. So 3 hours per day here is x bar. So 3 hours per day, it's x bar. This is the sample mean. And the S, the sample standard deviation, is 1.5. Okay, so let's write these components here. So we have x bar is equal to 3 hours. We have S is equal to 1.5. We have confidence level equal to 0.95 or 95%. Okay? Okay. So, first question here. What is the sampling distribution of the sample means in this case? This is the first question. Of course, this is related to, if you remember, to chapter number 7, the sampling distribution of the sample mean. So according to the central limit theorem, the sampling distribution of the sample mean is normally distributed, which means it's a normal distribution, with mean mu and standard deviation sigma divided by square root of n. And because we don't have here sigma, we have s, so we will say s divided by square root of n. Okay? This is true if the sample size is large enough. And according to the central limit theorem, the sample size is large enough if n, the sample size is greater than 30 observation. So n here is equal to the sample size we have here. So the sample size is 223, if you remember. So this is n, 223. So n here is large, right? Because it's greater than 30 observation. So you can apply the central limit theorem. So we can say the sampling distribution of the sample means of course the sample means is x bar, is what is normal distribution with mean mu, and the mu here is equal to 3. With mean mu and standard deviation s divided by square root of n. Okay? Okay. So we need to estimate now the second part. Is the sample size large enough? We'll say yes. The sample size is large enough. Okay. N here is equal to 223. Okay. So we can apply the central limit theorem. So this is the answer of the first question. When someone asks about the sampling distribution of the sample mean, first you have to check if the sample size is large enough or not, and the large enough, n is equal or greater than 30 observation. Something else. Of course, this to apply the central limit theorem, n must be large, but sometimes n is small, but the actual or the original distribution is normally distributed. So in this case, also the sampling distribution of the sample mean is normal distribution. So if remember, we have two things there. The first one, regardless the sample size, if the population is already normally distributed, so any sample from this distribution or from this population is what is normal distribution, regardless the sample size. The second thing is the central limit theorem. If you don't know the population distribution, if it's normal or not, in this case, you have to have a large sample in this case. The largest sample is 30 observation or more. So you can apply the central limit theorem, and then the distribution of the sample mean is normally distributed. Don't forget that, okay? Second question we have here, what is the standard deviation of the sampling distribution? We already know from the central limit theorem is what? It's what? S divided by square root of n. So the standard deviation of the sample mean, sometimes we call it sigma x bar, is equal to sigma divided by square root of n. Okay? But if you don't have sigma, you have what? The estimate S from the sample. So you can substitute it. So, or you can, because we don't know here the population standard deviation sigma, we have S, so you can say sigma x bar hat, this is the estimate for it as well, is equal to S divided by square root of n. Or you can say directly SD, the standard deviation for x bar, that's fine, no problem. So how much is this one? So SD is equal to, S is equal to 1.5 divided by square root of 223. So this is the standard deviation of the sample mean. Use your calculator. Does it work? Okay, I will use Excel because the calculator, the battery is dead. So it's 1.5 divided by square root of 223. So we have here 0.1, we can say it's a 0.1 because we have 0.10044, so we can say it's a 0.1. Okay? Okay. So this is the standard deviation, or sometimes we call it the standard error of the sample means. Both definitions for sigma hat x bar the same, no problem at all. Once you have the standard deviation of the sample mean x bar, you can construct the 95% confidence interval. So here we need to calculate the lower limit and the upper limit of the 95% confidence interval. So as I said to you, our formula to find these two limits is x bar plus or minus t score times the standard error, or the standard, sometimes we call it SCE or SCD, it doesn't matter. We already know that it's S divided by square root of n, okay? I will say now SCE, for example, okay? Again, SCE is S divided by square root of n, okay? So x bar, we already have it. X bar is equal to 3, plus or minus. T score, we don't know it, but we will find it right now from the table. And the standard error, we already calculated it from previous question. It's a 0.1. So we have here 0.1. So all we need to find what T score. To find the T score, you need two things. As I said to you, T score, you need the confidence level, and we already know it from the question. It's 95%. And the degrees of freedom, df. And the df here is n minus 1. N minus 1. Okay? So n minus 1, we have here 223 minus 1, so it's 222. Okay? To find the t-score in general, as I said to you, you have the table, or you can find it by any statistical software. Here we use Excel, and I will show you how to find it as well. So if you go to T distribution, as you can see here, in T distribution table, you have the confidence level in the first row up there. As you can see here, you have 80%, 90%, 95%, 90, 80%, and so on. In our question here, we have 95% the confidence interval, so we will use this column. The degrees of freedom is 222. So if you go to the first column there, and you try to reach the end, you will find what? That the last number is 100. you don't have more than 100. Why? Because if you remember, one of our T properties is what? When the sample size is large enough, that means T distribution is equal to normal distribution in this case. Okay? So as you can see here, until 100, you have these values. More than 100 degrees of freedom, you have what? These scores. And because we have N here, or DF, is 222, so we will use the last what? The last row in this case. Okay? And because it's 95%, so this column, so T score is what? 1.96 in this case. Okay? So this is T score from the table. Okay? So T score now is 1.96. Okay? So now you have everything to find the confidence interval, 1.96 here. First, find what? The margin of error. What is the margin of error? Is T score times the standard deviation or the standard error. Okay? Which means the result of this multiplication. Okay? So you will multiply 1.96 times 0.1. Okay? And then add it and subtract it from the from 3. Okay, we have 196, and then you will find the lower limit and the upper limit. So the lower limit and the upper limit, as you can see here, will be 3 minus 0.196, and here will be 3 plus 1.96. Okay, so we have the confidence level now. So we have here 3 minus this number. So we have 2.804, and here we have 3.196. Okay. Okay. So between these two numbers, we estimate that the population average within this range. Okay. So any value between 2.804 or 3.196 can be the population average. Okay. With confidence, 95%. Because don't forget, we construct it for 95% confidence level. Okay. Okay. Next question. Here, we have Michelin tires would like to estimate the average tire life of its latitude. Tow tire is terms of how many miles it lasts. Determine the sample size needed to construct a 95 confidence interval with a margin of error equal to 2,000 miles. Assume the standard deviation for the tire life of this particular brand is 8,000 miles. So in this question, we need to do what, or to find what? To determine the sample size N. We need N, the sample size needed or required to construct the 95% confidence interval. Okay? So we need to find N. N is missing. Okay? If you remember, we have a formula to find the sample size. We have one for the proportion, and we have another one for the mean. For the mean is equal to what? If you remember, sigma square times z square divided by m square. If you remember, m is what? Is the margin of error. So we need these three things. Do we have them? Let's see them. We have a margin of error equal to 2000. So we have the margin of error. So it's 2000. We need what else? We need sigma, the population standard deviation. Do we have it? Yes, we have it. Assume the standard deviation for the tire life for this particular brand is 8,000 miles. So this is what sigma. So sigma is 8,000. Okay? What about Z? Z score. We don't have it, but we can find it from the table. Okay? Z is related to what? The confidence level. And the confidence level here is 95%. This one. So if you remember, Z score for 95% is what? It's 1.96. If you remember that. Or you can find it from the table. As I will show you also again how to find it from the table. But if you have 95% confidence level, so Z directly is 1.96. Okay? What if you have different confidence level and you wanted to find the Z, as I said to you, from the table? In this case, you will do the following. Okay? So you will draw the standard normal distribution like this. 0 in the middle, of course, because this is the standard normal distribution. Okay? We need what? Confidence level 95%, which means the area here between these 2 points is 0.95. And you want to find Z. This is what we need. Okay? Of course, Z here is negative and the other one is positive. We just need one of them so you can use it as a score. Okay? Because these two scores are symmetrical about 0. Okay. To find it from the table, you have to know the area to the left of Z. Here you have two Z, negative Z and positive Z. Which one is easier to find the area to the left? Actually both, but the easier one is negative Z. How to find the area to the left of negative Z? So easy. The remaining here, because the area under this, the total area under this curve is 1. So the remaining is 0.05, right? Don't forget that you have two areas here, this one and this one. So you have to distribute this number among between them. So divide it by 2, so you will have 0.025. Okay, so the area here is 0.025 and also here is 0.025. Okay, now you know the area to the left of negative Z. So you can find the negative Z from the table now. Go to Z table. The negative one, of course, because we know it's negative. And look for the closest number to 0.025. So 0.025, it's the closest number. Actually, we have the exact number. It's here. 0.025. So this area to the left of what? Negative 1.96, as you can see. Okay, so this score is what? 1.96. So we have here negative 1.96 and here also 1.96. Actually, we need just one of them, and so you can construct the confidence interval, as you can see here, 1.96. Okay. So this is the way of getting what? The Z-score from the table. What about Excel? If you would like to know Z-score from Excel, in this case, you will use this function. You will use, of course, equal before the function, norm dot s dot inverse, IMV. Okay, and then put here what? The area, 0.025. This is the area to the left of Z you would like. Or the area, or you can put any other area if you have different confidence level. Okay, but the more important is to determine the correct area to the left of Z so you can find it. Okay, so this is what you need. Okay, so you will have 1.96 from Excel as well. Okay. Yes. Okay. So now we can find the required sample size to construct the 95% confidence interval. Sigma is 8,000. Don't forget it's squared. Z 1.96 squared. And the margin of error is 2,000. So we have 2,000 and also it's what? Squared. Okay? Use your calculator, use Excel as a calculator and find what? The result. Okay? So I will do here in Excel. So we have equal 8,000 times 1.96 divided by 2,000 is equal to this number square. So we have 61.4656. 61.4656. Okay? As I said to you, for this formula, n, always round the result up. Even you have 61.0001, always round it up to the nearest integer. Okay? Okay. So you need at least 62 to have 95% confidence interval with a margin of error or margin of error 2,000 miles in distance. Okay? Okay, so this is the required sample size. Okay, another question, but this time for the proportion. Okay, as you can see here, we have a recent GSS asked if the wife in a family wants children, but the husband decides that he doesn't want any children. Is it all right for husband to refuse to have children? This was the question. The number of sample size, we have 598 respondents. Among them, 366 said yes, and the remaining 232 said no. Okay, we need to find or to construct the 90% confidence interval for the population proportion. As you can see here, what? Proportion. It's not the average like the previous examples. For who? Who would say yes? Okay, because also we can construct a confidence interval for who said no, because both are proportions. Yeah. Okay. So in this case, what is the 99% confidence interval? Okay, for the proportion. So for the proportion, it's a p hat plus or minus z score, okay, times p hat square root of p hat times 1 minus p hat divided by n. Okay, so this is the confidence interval for the proportion p. Here we need to estimate P. Don't forget that. We need to estimate P, the proportion or the probability of success from the binomial distribution. Okay. So we need to estimate P hat or to find P hat first. What's P hat? P hat is X divided by N, if you remember. And we said that X is what? Huh? The number of successes. Okay, this is the number of successes. And N equals the sample size. So from the scenario here, N is equal to 595. And the number of people or husbands who said yes is what? 366. So this is what is X now. So P hat is equal to 366 divided by 598. Use your calculator to find the estimate proportion. So we have 366 divided by 598. So we have here 0.612. So this is the estimated proportion. Okay. Okay. Once you have it, you can find what? The standard error or the standard deviation of the the sample proportion, okay? And as I said to you, this standard deviation or standard error, both are correct, is what? Is P hat 1 minus P hat divided by M. So this is the standard error or the standard deviation of the sampling proportion P hat, okay? We already have P hat, so all we need is to apply this formula. So we have here 0.612 times 1 minus 0.612 divided by the sample size 598. Okay, use your calculator so you can find the standard error. Okay, so we have here let's say SQRT, this number times 1 minus this number divided by 598. So we have 0.0199. So we can round it to 0.02. Okay, so it's 0.02. So this is the standard error or the standard deviation of the sampling proportion, as you can see here. Okay. What about Z? We need here to construct what? The 99% confidence interval. Okay, so the 99%, if you don't know it, how to can find it, as I said to you, the previous method here. Draw, let's do this here. Draw the curve. 0 here. Between these two limits, we need 0.99. So you need to know Z here and Z here. Okay, so the remaining is 0.01. Divide it by 2 because you have two symmetrical area here. Okay, so you have 0.005 from the table. So now you know this is 0.005 and this also 0.005. Once you know the area to the left of Z, you can find Z from the table. right? So 0.005 from the table. We go to the table here because it's negative. The closest number to 0.005 we have here 0.0049. This is the closest number to 0.005. So this score is negative 2.58. Negative 2.58. Okay. So now you know Z. Negative 2.58 or 2.5. Of course, we need just 2.58 the value. So Z here is 2.58, and we have P hat, we have the standard error. This is of course the standard error, SCE. So all you need just to substitute these numbers here. So you have 0.612 plus or minus 2.58 times the standard error we have here 0.02. Okay? Find the margin of error, which means you multiply Z score by the standard error. So we have 0.612 plus or minus. Use your calculator. So we have this number times 2.58. So we have 0.0514. 0.0514. Okay. Now you can find the upper limit and the lower limit for this confidence interval. Okay. So the lower limit, the upper limit. Of course, the lower limit is what? Is 0.612 minus 0.0514. The upper limit will be 0.612 plus 0.0514. So you can find what the 90% confidence interval. Okay. Okay. So use that. So we have this minus this number. So we have 0.56. You can say 0.561. And we have this plus this. Plus 0.663. Okay, 0.66. Okay. So within this range, we may have the population proportion P with confidence 99%. With confidence 99%. Okay. Okay. Next question for the same scenario. How does it compare to the 95% confidence interval? Okay. So that means you need to find the 95% confidence interval for the same scenario. Okay. So, or you will have this, everything is the same except what? Z. You will have different value for Z score in this case because the confidence and level is different. Okay. So in this case, you will find P hat plus or minus for 95% confidence level. The Z score is what? 1.96. Okay. Don't forget that. And then times the standard error. So you can find the lower limit and the upper limit by the same way. So you have 0.612 plus or minus 1.96 times the standard error 0.0514. 0, 2. Okay. Okay. So find the margin of error. Okay, so 0.612 plus or minus. The margin of error in this case is, we have 1.96 times this, so we have 0.039. Point, uh, 0.039, so we can say it's a 0.04. 0.04, yeah, 0.04. Okay, so the upper limit and the lower limit will be 0.612 minus this. So we have 0.2573, and the upper limit is this number plus the margin of error. So we have 0.65. 0.651. 0.651. So this is the lower limit and the upper limit for the 95% confidence interval. Okay? Okay. Of course, you will have different values, as you can see here, between the 99% confidence interval and the 95% confidence interval, because we have different z-scores or confidence level in this case. Okay. Which one, or to comment on these two confidence interval, as I said to you last time, when we increase the confidence level, this will affect on the width of the confidence interval, right? And when we increase the width, that means the margin of error increased, right? So you will have, yes, or you can have for the 90% or more values possible for the population proportion, but the precision is lower than the 95% confidence interval. If you remember, we talked about something called the margin of error or the accuracy and the precision. Okay, if you increase the z-score or the confidence level, this will increase the margin of error. When you increase the margin of error, that means make the width wider for the confidence interval. That means you will have more values for the population proportion. But which one of them, of course, we don't know, because all of this is just an estimation. Okay, 90%, yes, it's a very good confidence level, because you increase the margin of error, but at the same time, it's what the margin of error is wider, so the precision is lower in this case. Okay, so this because of that, we always prefer the 95% confidence interval than the 90%. So read this part. As you can see here, the inference with the 90% confidence interval is less precise. Why? With margin of error equal to 0.05 instead of 0.04. Having a greater margin of error is what is a sacrifice for gaining a greater assurance, 99% rather than 95%, of correctly inferring where B falls. We have here something about the medical study. So a medical study that uses a higher confidence level will be less likely to make an incorrect inference, because in this type of studies, you are dealing with people, the lives of people. Okay, so there is no way to play with this. Okay, but it will not be able to narrow in as well on where the two parameter values falls. Okay, so if you remember, I said to you, we select the confidence level based on the type of study. Some studies allow us to have wide a margin of error. Some other studies, like the medical studies, we cannot do something like that because it's very critical uh, to the lives of people in this case. Okay. Okay. So this was a quick review on the confidence interval for the population proportion and population average in chapter number 8. Okay. Okay.